So, welcome everybody. Many thanks for joining my presentation of a very special spacer material. It's called TPS, Thermoplastic Spacer. So hopefully everybody is refreshed and had a good meal to be attentive. And so my name is Stehr. I'm working for Bystronic since 5 years, responsible for the sales activities in Central Europe. And yeah, the next 20 minutes I would like to talk with you about this TPS material and how you can increase your productivity in the IG production and how to increase the product quality. First of all, a few words about Bystronic. So we are a machinery manufacturer since more than 50 years, founded in 1966 with more than 400 employees worldwide. So we are mostly focused on the insulating glass manufacturing machines, but also for automotive glass, producing handling equipment, and also special fields like display glass, and for sure everything supported by a very good service. Yeah, in the next 20 minutes I will talk with you about the product itself, about the production process of the TPS. Then I will tell you, I will introduce you to some features, and also how it increases the lifetime of your product. Let me start first of all with a small video that you get an impression what TPS is. It is a butyl-based material which will be applied directly to the glass instead of a rigid aluminum spacer, standard spacer. It will be applied by a robot system, applied directly to the glass, driven by data. And with this process, with this material, you've got, you've got very good flexibility in your production without any downtime for setup, for changeover. So this shows you the TPS application process. And well, the main difference between standard spacer and the TPS is when you take a look to the rigid spacer, you've got usually 3 parts. You've got the spacer itself, you've got some desiccant, you've got some butyl, what you apply on it. And with the TPS, you've got only one material still, which comes from a barrel. It's a butyl-based material with desiccant inside and will be applied directly to the glass. So this will reduce enormously your production cost and also reduce the complexity of your production, what I will show you later on. So since the TPS does not have any metal insert, so you've got the advantage that at the edge zone, it's the heat insulating is much more improved instead of aluminum spacer. So that means you've got reduced condensation at the window. It ensures a maximum gas tightening since cross-section of the butyl, which is applied to the glass, is much higher instead of a standard spacer. And for sure, since it's a robot-driven process, it's an automatic process, so you've got a wide range of designs possible. It's a very flexible process. So for sure, different sealing materials can be used: silicon, polyurethane, polysulfide, and also a reactive hot melt. So in this case, you're also very flexible. And the TPS material, in the meantime, is available now from different vendors. So you're not only focused on one vendor. So you have got a free choice of the material manufacturer. So the application field is also very wide. In the commercial market and also in the residential market, in the automotive industry, it's possible to use it, and also for special applications in trains, and also for solar applications. It's also, we have got some projects where this material is used. So when we take a look to the production process, let's compare it to the standard production that you usually have. You have got The IGU production in this lane, beginning from the loading and application, assembly and sealing. And then you've got a second production process for the spacer material. For the spacer, you've got the cutting, bending, desiccant filling, and butiling. So, and with the TPS process, you can eliminate totally this additional process. So that means you've got a streamlined production. You can reach a very lean production. You can reduce the complexity, and also for sure the failure rate in the frame production. And also you do not have any logistic problems since the material will be applied directly to the glass. So, and for the IGU line, it means only that you will apply one additional section inside with some transportation belt, the TPS robot, and that's it. It does not increase your complexity of the IGU line, but it helps you to to have the possibility to run an automated IGU production. You load the glass, then the IGU will be produced automatically without any operator influence for the assembly, and then you have got only the unloading section. So it helps you to automate your production. So available is this material. You can use it up to 20 millimeter spacer width. It's usable for all formats, and very important thing when you take a look to the production process is this part here. We call it the joint of the TPS material. So for sure in the production process you have to take a look at it, that it's in the edge. So that means it's invisible then in the window. And also, it's very important that you have got an overlap of this joint. So you see some applications where it will be put together and then will be heated and smoothed. And so if you use it with an overlap and then press it in the assembly robot, you can reach the maximum gas tightness with this material. So another big advantage during the production process is to have a control of the thickness of the IG unit. So with a rigid spacer, we've got this example here with laminated glass 8.7, then a 3.9 float glass, and then the spacer material, the width of the spacer is fixed. You do not have any influence on this measure. So that means you will produce IGU of 28.6 millimeter without any influence to reduce it. And with the TPS material, you've got the advantage that you can calculate the thickness or the width of the spacer, which is in this case 15.4, and with accurate pressing in the press robot, so you can reach exactly 28.0 millimeter. So exact control of the IGU thickness. So next advantage of this process is that you have got a very big flexibility. If you produce glass with 10 millimeter spacer or 8 millimeter spacer, 12 millimeter, you do not have any downtime of the line for changeover. So since the system is data driven, in the nozzle the spacer width will be adapted automatically, and you are very flexible in your production process. Since it's an automated process, you'd also have no offset between the two spacers in a triple IGU. Usually, when you use a rigid spacer, you've got at any place you've got some offset. With this system, you have got a very accurate position of the two spacers. So, and on this slide, let me show you some samples what you can produce with a TPS. So you've got a very big field with what you can produce, different shapes. So there's nearly no limit for the shapes. Also for the structural glazing, it's one 3-4-sided step unit which can be produced, and also some very special glasses possible with it. All right, let's talk about some additional features of the spacer itself. We've got a comparison for the Psi values in comparison to the standard spacers that you can get on the market, and with the TPS you can reach a very, very low Psi value. There's only one spacer material which is slightly better, but with the TPS you can reach a very, very good Psi value. So, and due to the very good Psi value, and also since there is no metal insert in it, you can also reach a very good, a higher temperature inside. So in comparison to aluminum spacer, you've got usually at this edge, so it's 5 degrees and more than 5 degrees warmer in comparison with the TPS material, which ensures very good temperature distribution on the glass. So also we got a study from BASF. It's a long-term study where they compared different spacer materials which are available on the market, and they checked a lot of items for costs and for the economic influence, and so they found out that the TPS is the most efficient, economic efficient system that you can get on the market when you calculate everything. And that beginning from the production process, and then later on in the installation of the building. So then let's talk about the final product, the IG unit. What about the lifetime? So we have got two factors which influences the lifetime. One is the moisture penetration over several years. So, and I've made several tests, and you see the TPS material has got the lowest moisture penetration in comparison to other systems. And the second point is the gas leakage rate. So, and also the TPS material in comparison to other systems is the lowest gas leakage rate that you can get. So let me tell you the two reasons why we reach a very good lifetime for the IGU. One is the fact that the material, the spacer material, stays flexible. So that means you do not have any influence due to the pumping effect. So any increases or decreasing of the temperature inside the glass. So the material stays flexible. It stays at the glass. You do not have any peel off of the butyl. And for sure, since the cross section of the butyl connection is better at the glass, so you can reach the maximum gas tightness. So, and when you take a look to the fact that the initial moisture penetration during the production process is also much lower in comparison to a standard frame, because when you produce a standard frame with a desiccant, you put it to the line, and you've got the production environment, and so some moisture from the outside from the environment can get into the frame, so you can reduce this this disadvantage with the TPS, since it comes from the barrel directly to the product. So also, since the material stays flexible, so what about the stability of the material? So in cooperation with an institute, we made a test and made a load test of 20 hours with 2 tons. And after releasing the force from the IGU, it got back to the original thickness. So you do not have any disadvantages on it. So stability is similar as with a standard spacer. So also the system is proven by all renowned institutes. That means we have got there are certificates worldwide for the TPS IGU. And yeah, also when you take a look to the references, there are buildings around the world where TPS is used. So, and with more than 120 TPS lines installed worldwide, you can see several buildings where this system is used. So, let me come to a short summary of this my presentation for the TPS. So you've got with the TPS process, you've got the automated application process. It's let me say simplified. So you only feed the line with data, and then the complete production process or the space application goes automatically directly to the glass. So in the production, you can reduce the complexity, you can reduce the failure rate, so you can reach a lean and automated production. So the thickness compensation, that you can produce the thickness that you really want to have at the end. Then for sure, we have seen a lot of different shapes possible. It's very flexible to change over without any downtime, and so the surface temperature is also higher in comparison to other systems with lower condensation at the glass edge. So, and based on the studies, so you see that the TPS is the most efficient spacer system that you can get on the market. So, I think you have seen that TPS, how can the TPS system can increase your productivity, can bring down your production cost, and also increase your product quality. And now at this point, so I'm open for questions. Please feel free to ask.
The gentleman here has a question.
Yeah.
I would like to ask what's the extrusion temperature during the process and also the temperature resistance of the spacer?
So it's more than extrusion temperature is 95 degrees. Extrusion temperature.
And how about the temperature resistance? For example, in France, you have regulations that the spacer should resist more than 60 degrees. And how about this spacer? The temperature resistance.
So
like how?
Yeah. So the material will be applied with 95 degrees, and every temperature which is lower, there you do not have any issues that the material will peel off.
But sometimes on facade, if you have a structural glazing, which on the side you have a black color and it will absorb more heat. So it, potentially it can raise up to more than maybe 100 degrees C.
Usually, the system is used since more than 25 years, and is also used in the facade business, and there is no claims in this case that they've got issues with temperature in this case.
In row number 5, there was a gentleman who had a question as well.
Well, my question on your application, was there any issue with sagging the front paint versus the rear one?
I'm sorry, I didn't get the question. So what?
Since the product is silicone, and
Yes.
when you apply two-piece, did you
Okay.
have any issue with sagging two panes versus each other?
Well, right in the beginning, so you cannot use a standard TPS with a standard silicon. It has to be the vendor call it reactive TPS material. Then you can use it with a structural silicon, and you do not have any reaction on it. So in the beginning, there have been but this is more than 25 years. I've got one or two issues with the reaction, but since they have got the reactive TPS material, so there is no influence from the silicon.
So with a standard spacer, usually the failure is because the butyl the PIB separates from the glass. So since that isn't what happens with the TPS material, what's the most common kind of failure mode for this material?
So we know it is lower, for sure. But so we can only measure the gas leakage rate inside. So we cannot say okay, it's 5% better instead of the. So only the test with the gas leakage rate is available in this moment.
Question at the front.
Yeah.
Just the radius of the corners, like can be controlled or can be a sharp corner or?
Can be controlled up to 6 millimeter radius.
Sorry, even with the bigger thickness of the spacer as well?
Yes, also with the bigger thickness.
One at the back, I think. Time for another one.
You had a slide showing moisture essentially permeating from the secondary seal into the TPS spacer.
Mm-hmm.
To what depth does that moisture reach before it's blocked? And how does that relate to, for example, edge deletion limits related to the TPS spacer?
It's a very good question. So I have to say, I do not have an let's say the depth of the penetration. So maybe somebody from the audience have got the answer. No. Okay.
I think we're.
Okay. Maybe we can talk later on this topic. Let me check this out, and then we answer this question later on, please.
Yeah.
Yeah.
Thanks, Marco. I think we're
Okay.
just about done with questions. I have one relating really to the sheer strength of the product. Sometimes when you make a large unit,
Yes.
because the self-weight of the glass, it relates to the other question earlier that you get some shear forces into the spacer bar. Some spacer bars break, unfortunately. How's the TPS in terms of shear?
Of
The shear strength. So how is it reacting when, it's related to the other question, how it reacts when one glass slumps or tends to move? in relation to-
it's similar to the rigid spacer, because the stability of the unit will come from the secondary sealing.
Okay.
So, because with the standard spacer, you only have a small rope of butyl which sticks to the glass, and when the glass slips down,
Okay.
similar with
Yeah, it's just some experience in the past with those better performing thermal spacers like Swiss spacer, not quite as strong as stainless steel spacer.
Yeah, but the bottleneck, so the weakest part of this complete process is the butyl rope that you have.
Okay. No,
Yeah.
very interesting talk, Marco. Thank you.
Okay, thank you.
we'll wrap that one up for now, right on time.
Yeah, right on time. Okay.
Thank you.
Thank you.
Hi there. Did you like what you just saw? If you did, why not like the video? Drop us a comment below, as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao.